So please welcome Hanif Kara.
Thank you. Okay, thank you. Thank you, Tyréns in particular. So I'm going to speak from a split personality. I'm going to speak from the Tyréns umbrella as an engineer, but unfortunately I also have to keep reminding myself that I'm partly an academic. So you have to bear with that, and I'm going to try and do it in English and keep you awake. So there's a lot going on for the next 45 minutes. Not 40, I'm going to take about 45, I think. But,
Really?
Yes.
Well, we'll see about that.
Okay.
Yeah.
I didn't know what the audience was, so the basic position that I wanted to start it from, so that there is no confusion, is my own views on what constitutes design research, how we undertake that research, and why it's necessary. Design research is very different from scientific research, and it's very difficult to try and articulate it, but in essence, most scientists would consider themselves normal and architects as casual. And the design research is particularly prevalent in that area. So my position really is splicing the two together. And when I was appointed a professor at Harvard, that was the first time they created a chair for somebody who can sit between the two places. So what I'm going to talk about mostly is the gap between the two and how you join the two as much as I can. I'm going to do it through 4 very good examples, and then the last bit, which you really have to stay awake for, is the bit that Tyréns are currently sponsoring. I'm not going to read it all, but in essence, I think the scientists on the one hand are going crazy, and you see it more and more forensic, to the extent where scientific research is becoming so difficult to fund that all designers actually, and it's always protected so much that design and application can't get to it most of the time. There's so much protection of it. In my view, that's not good, and I'll show you examples of why. At the same time, I think that what scientists want to do is they want to know what it is, whereas designers, I think most scientists want to tell us all the time, designers want to change what it is. This is essentially what I've discovered, at least in the last 5 years. Why is it that we don't talk the same language? Because of the casualness of design research, it doesn't always have an answer at the end. It's omnipresent in stages. The question they're trying to answer is how to use it better than us, I think, better than scientists. I sit, therefore, in this compromise zone as an individual, as an organization, which kind of confused in a way because it doesn't really deal with value. It tries to deal with perceived complexities. It tries to deal with efficiency. But there is a zone that's conflicted, and many people draw this diagram, but I like it because it kind of places us in this cube where we seem to be able to do all these things. We're not always absolutely being an engineer or an architect in the work, and I'll show you examples of that. So in the beginning of this way of thinking, there are many thought processes, but probably 10 years ago, 12 years ago, the digital, we're now in the post-digital, the digital world, and probably Stephen Wolfram was one of the first artists within the science world, talked about how we can now simulate everything and basically make all the invisible visible. And that was the big shift in certainly design research 10 to 12 years ago. What seems to have happened then is that a lot of that stuff has been made into this big ship because the casual people can't really use it well, not as well as we do as scientists. The example we saw with the really weapons-grade software that we were listening to earlier, it's just impossible for designers to handle that because they don't have PhDs, most of them. But what tends to happen is they take all this software and it becomes a huge ship, usually, which is made of metal, and it no longer has a compass. So what tends to happen is it goes in a direction that doesn't really get them anywhere because it's just so complicated for designers. That's my view. That's not necessarily a bad thing. You can turn it back into, as I'll show you, into a positive. One of the areas that they've been lacking in enormously in both worlds is how we actually understand materials, and I don't want to go through the details of this, but if I can just give you one particular pin on it, A Canadian architect once said that most architects wouldn't know silver if they were standing in it and it was boiling. What he's trying to say in a way is that they don't really understand materials, and that's one of the dilemmas for me. I'm going to set my scene and then show you the example. The other big difficulty we have as design research, within design research and practice, is there's no one funding testing for real. So we have to keep going back to the scientists in order to find out what we can do. And the scientists don't always want to give us information. So the only way we can fund our projects is through real life projects if we want to do any research that's real. That goes for robots, it goes for everything. So that's the scene. What we do in the office in order to recover from that is we invent a lot of small projects all the time, and these are done not for profit. This have been in the beginning for the last 20 years. We've been doing lots and lots of projects, either with shape, with material, with an idea, and we test them, we even put money in some of them, but often it's self-funded, and it's funded in order to find a particular piece of research that we can then put back into the system. This has been pretty successful, and the kind of organization that we've done to use that is from the beginning of the practice. Within the organization, we've got a not-for-profit element. So about 10% of the staff have always been other disciplines, not structural engineers, and they don't have to necessarily make a profit. So it's not about immediate profit, it's a bigger horizon. It's been a 20-year horizon. And within that group, we're teaching, we're researching, we're doing small projects, we're working with artists, we're working with scientists, sometimes and material experts. It's the only way that we can connect. And we haven't done it lightly. So over the last 20 years, including KTH here, we've tried to not be spectators in the world of education as practitioners. We've tried to go and embed ourselves within the system. So many practitioners go to design schools just to pick up the next fashion so they can sell it, or pick up the young, bright architect, they can employ them. We've avoided that mostly. So through these institutions, we've tried to actually embed the part group that we have within the system. So we're also engaged in teaching design and trying to pick up from that or inflict our thoughts early on when the minds are first forming. I want to show you 4 examples of what happens when you behave like that. So that's 20 years of thinking, of very, very quick examples. Complex geometry is one, which is a fascination for everyone all of the time, and there's lots of software people are playing with. Just to show you a very quick example, I twisted that last year because I think the Baroque, in particular, San Carlo in Italy, when Borromini did this, had much more intelligence than most of our software. If you look at the symbolic, the religious, the geometry, and the many layers of this particular building, how would you have interpreted it today? So what we did is a very quick 14-week studio at Harvard last year, with Ciro Nale, who is a very close friend of mine, on looking at how he made that building, and we visited it and understood the materials. And then we sort of took some of the information from it and tried to move it to a potential dome or a project in Bryant Park in New York. So a very quick exercise, 13-week exercise, for an option studio, where we take all the knowledge of Borromini and try and hit it very quickly with all the tools we have. A whole series of projects came out of that, which were very, very successful and will be published. The second type that I want to talk about is history. So the longer horizons are sometimes very, very useful. We don't have to find new thinking. The work of Buckminster Fuller, for structural engineers, some kind of a god, historically has been misunderstood or has been treated as religion by architects. It's the most tested work and nobody questions it at all. So what we did in the last, because his anniversary comes up this year, one of his death. So we worked with Santa Fe, San Diego University, with Daniel Lopez, who's one of the professors there, to create the Spherical Atlas there of all his work, his thinking and his writing. So we've been doing this together for quite some time, just trying to understand how he invented new language, like Dymaxion is dynamic and maximum. So you look back in history, you see that we're actually repeating history again and again. So today we talk about parametrics and all the other sort of languages we're creating in order to understand, even back to what Borromini did, for example. So when we go back to history, we try to understand it. We took that as a sample, and we looked at the latest tools and applied everything to it, all the forces that we want. Looked at it very forensically, spent about 2 years of our time trying to find out what was so interesting. And what we found was actually he wasn't interesting. He just patented some ideas. And we also found that most of his domes were just too big and highly inefficient, too heavy. And then we said that in conferences. And what happened is we got challenged by his family and his lawyers and all the other people that kind of tried to protect that. So we went on to prove it. We're working with a couple of stadiums in Qatar. In one particular one, which is an existing one, our brief was to take a football and cut the top of it. And the client came to us with a Borromini model and said, this is what we want. This is a lay client who at some point read about, a Buckminster Fuller model and said, this is what we want. It's 200 meters in span. So we did do the analysis that work we'd done. We applied all of the Buckminster Fuller systems to it to see what we could do. Obviously, you'll appreciate, most engineers will appreciate that as we started to erode this and try to make it more and more optimal, what we found is that we had to make it shallower and putting a hole in it, make it more difficult, and so on, concluding basically that if you try to build what he said, it would be nearly 3 or 4 times the cost, not just the surface area. So we've gone on to take that particular idea from history, reapply it to today, and are about to start construction on this particular one. But the most important one that I think I need to show you is from that history. As of now, we're working for probably the most advanced technology company, Google. So in Santa Fe, they're building their new city, 5 million square feet, which we're working with Bjarke Ingels and Thomas Heatherwick on. Again, the people at Google, who are the brightest, were always referring back to Buckminster Fuller. We want to build a city like he envisioned nearly 60 years ago. And we're just in the middle. I can't tell you too much detail on this because I have a non-disclosure on it. But basically, we're applying this to the most latest way of thinking. And we're about to, again, build the first building in this case. The whole site is a mini city. So some of the analysis work is reapplied. Design research is applied to real work. Low-tech and high-tech is a really important discussion. And sometimes these ideas are born out of frustration. We get so frustrated with the industry not giving us what we need. So recently we've looked at Africa, which seems to be the playground for everybody who's got anything to do with architecture. They want to workshop in Africa just to treat the poor in a way that they shouldn't be treated. And in some ways, the Africans, in response, are doing things that are not so good. So we felt that we could make a statement, a political statement, and we picked our own city, which is Addis Ababa in Ethiopia. And we, instead of working with an architect, we worked with a local school, and Olafsson, the artist, because we didn't want too many constraints. And what we wanted to show is a city that's growing almost at the same pace as Seoul in Korea. So in relative terms, rapid urbanization, increase in knowledge, high-tech industries are building up. We went there for 3 weeks, looked at what they make, and what is incredible is all the craft skills that they have. And then we applied that again through a month's workshop to try and make facades for them. So we, with the students and with the manufacturers, we've made some very interesting facades that they are now going to apply to some of their buildings. In fact, they wanted us to put these on the buildings when we were playing out there. So, we used, in this case, tin, leather, all sorts of materials, or bamboo. And I just show it to you as a contact between low-tech and high-tech, because it comes from a frustration of not being able to do that in the UK. And I'll show you an example later about that. Just move one more, sorry. The last of the examples I want to show you is tectonic examples, materials. So again, looking at history, and this is one of the courses that I'm working with Leira Senor, who's an architect, and we're experimenting with manufacturing techniques for the last 4 or 5 years, where we take the work of many well-known engineers and architects and designers, in this case the German artist Hohr, and we apply this to get students to understand the old geometries, the old ways of making things, and then get them to reproduce these things in more complex ways with the hope that something will come out and go into a building. In this particular case, we've looked very closely at the work of Isaac, the Spanish engineer who did an amazing array of projects in Spain, for those of you who know his work, with post-tension beams. So we created a new way of actually trying to make these things work through these projects. So it's a master's course and an elective 14-week course where a group of students basically plays around with the tools, plays around with the geometry until they get to a point where they're forced to make and test something. So I'm going through this very quickly. Again, when we were doing this project, it kind of accidentally connects to reality, because when they were making the molds, what we found is just a simple technique of wire cutting foam in order to make shapes, which to most engineers is easy. To make it in a complex shape was very, very interesting, even at a small scale. And we learned so much from it that we managed to actually apply it to a very, very big project. So this particular project won a lot of design awards for the student. But for us, it's connected back to a real project. So now, going to shells in structures, these are shells for the King of Algeria. So this is with Zaha Hadid Architects, the new palace and the new home for the King of Algeria, or the President of Algeria. These shells, are not the geometries that engineers are used to. So one of the most difficult aspects is how to make them on site, and we're connecting them back to what we've learned in the research that I showed you. So here, this is the direct connection between the projects. So before I move to the projects, the Tyréns project, I want to show you a couple of other things. One is that we tend to publish a lot and not in technical magazines. So we tend to not do high-end, proven technologies in scientific research. Most of the office tends to contribute to the debate on design. And we find ourselves in that arena to be much more profitable if we want to sit between the border of science and art or architecture. It plays out like this. So taking towers before the recession, they were all kind of funny shapes. Some were very indecent, and they were doing these things just because they could. There was never a reason. They were forgetting little things, like they would make claims about the tallest concrete building without realizing that 20 years earlier we'd made oil rigs that were taller or as tall, or we'd made a steel tower. So the connection between hardcore engineering and architectural engineering is lacking. There's no communication across here. My own experience in oil rigs, doesn't frighten me to do towers at all, but you'll be surprised how people think it's specialist. And how do we apply that? So in London, the new district in Canary Wharf, which is called Wood Wharf, we've worked on the master plan. And one of the most interesting projects is the Herzog de Meuron's tower for a residential cylinder. It's essentially a very simple cylinder. But the kind of work we've been doing with software has allowed us to tie the tool, so make the visible invisible at several layers and several ways of doing it. These movies are not playing for some reason. But essentially, we have live conversations between how you make the structure efficient, but also measure the net floor, facade, all the metrics of how a building is designed today, or all the metrics of how a building is costed, is done through software. And as we are doing the most efficient structural system, the clients are looking at the area ratios, we're looking at deflections and so on. These should be playing live, and then you would see it, but for some reason my movies are not working, but that's okay. Oh, you can see it there. So what's now happening is that we're not deciding immediately to put a core in for stability. We're playing with it. We're allowing the architect and the client room, so we can go from a core, what happens, to outriggers. It's a very, very tall building, by the way. It's nearly 300 meters. Because the complexity of residential today, the uniqueness in any of these buildings, particularly somebody like Herzog de Meuron, demands this kind of conversation. So the positive side of the tools is that we're able to cross-disciplinary converse. We can talk about cost, construction, and efficiency in structure at the same time, which is proving to be, at least in this particular project, very, very helpful, I think. So you can see, rather than having a static measure of cost, we've got enough data, enough live data going on. So every time, in fact, the top units have just been bought by, the top 3 have first been bought by a very rich Russian gentleman. That's changed everything we're doing, but we're actually piling already. So it gives us this ability to flex a little bit with the staticness of the market. At the same time, it allows us to zoom out. So because we're working on a master plan and yet the first tower is being built, we're able to connect other software, not just CFD, but wind analysis, and the changes in the environment to the structural model very quickly rather than wait for the wind tunnel testing. So that's the kind of application of it. What's interesting is that that same application then goes back to the post-digital. So here in London now, this is a 26-meter high tower. We're working on parallel with the two, where the challenge for the client was to deliver a new tower very quickly. So if we don't do it within the next 2 years, the market is dead. We're responding to a market condition. And what we've done is, rather than kill the tower, 26 stories high, we've added 11 stories to the existing tower. Because what we've been able to do is measure the existing in a better way. We've gone in and done material tests, look at redundancy, new finite element technologies, and nonlinear analysis in order to allow the client to build up. Incidentally, we've also found that codes of practice have changed quite a lot. So factors of safety have been reduced. That allows us to build quicker something that is going to be half new, let's say, which I think is a very, very important, particularly Western Europe. Every city in Western Europe has got too many buildings, and you really need to think about not retrofit, but how to give them a 100-year life again in some way. So that's the building under construction. I'm not going to go through the details, but you can see that we played around with it a lot. That level of analysis is also quite useful for dealing with other things. So in Istanbul, a client has had a problem with his building, which is the Canyon Shopping Center. Some people might know. It's called the Canyon because it was designed like a canyon. Of course, when they opened it, the wind is blowing so high that ladies won't go shopping there. In that culture, it's very difficult. So the most expensive shopping center has been closed for quite some time. And the client came to us and asked us to work on it because it's already built. Not only to work on it, but he wanted to put a tower right next to it. So splicing all these tools, and we've been working with some of the people from Formula One on the analysis that they're doing. We've been able to take real-time data on wind on the site. We've been able to take finite element analysis of wind models, physical data, then do some tests on site, splicing these things together to find the problem. We found the problem. We can now solve it, but even more, we get to construct a tower right next to it. So these things are creating new opportunities that one could not really have seen a few years ago through the power or the brute force with intuition, the brute force of processing power, and going across disciplines with processing power, but having some idea about design, not just the scientific results that these things give. How do you respond to or interpret some of these things? I'm going to try and move this. Okay. I want to show you another application. So when the Olympics in London happened, I won't show you all of the buildings we did, but again, there was a pre-thinking from the environment that I told you about. So we strategically placed ourselves around a whole series of typologies, and every time a competition came out, we were able to respond with the research we'd done very quickly. So I just show you very quickly the most popular of the temporary pavilions, which was this idea of making the Coca-Cola pavilion, which was built, and probably the most successful one. Again, came from an analysis that was done about reciprocal frames in the horizontal, not in the vertical, and applying that randomness to give Coca-Cola an iconic model that we actually built. We've gone on to build a lot of pavilions and are working with Coca-Cola on a number of projects. The last example, at a building scale, then I move to city, is taking skins. This is again Harvard publication that we did with Fashid Musavi on the function of ornament, which then got out to apply to a number of buildings. So all of these projects, to me, in application, come back to designing better buildings. This was environmentally friendly as well. But they also go back to new ways of thinking. So this project here, I show it to you because this led me back to Ethiopia, because we tried to make ceramic tiles, a very simple idea of ceramic tiles with Islamic patterns that would allow us to change the window and make a building much more efficient. But the European system of industry did not allow us to do ceramic. The risk is too big. And yet, when you go to Ethiopia, it's the only way to do it. You know, you could do all of this in ceramic, but in the end, we built it as a metal. So sometimes the work is born out of frustration. Probably the most successful city scale is the Masdari Science Center, Masdari City, where Foster and partners basically used an old Arabic city, Wishibam, those of you who know it in Yemen, to look at how we could build a zero-carbon city. You can question the ethics of building zero-carbon cities in a desert, yes, but as an experiment, it's an incredible experiment. And there were at least 16 universities involved. We were engaged with the research. Then we went on to build the first model, the first module. They call it the District of Education. So that red block is where the science center has been built that will now research for the rest of the city. So you can see the direct connection again across disciplines, but also across education and practice that leads to incredible buildings like this. Because in this particular part of the world, quality of construction is not always good. And Foster and partners have achieved that remarkably well. But the most important thing about it is the post-occupancy measures. Most of our research, we don't go back to check whether it worked or not. You know, you can get the visual reaction, but in this particular case, there was a lot of work done by the architects with the mechanical engineer and us to show how we'd invented the city and what were the tricks we used from the old cities in Arabia, what materials we used, and then we've gone back to measure it. So what has happened is that we are finding that our streets are 4 degrees less in temperature at the same time in a very similar environment half a mile down the road. So saving 4 degrees of temperature, you can imagine the amount of energy we're saving. So it's really an incredible experiment. It needs an incredible sponsor, the government of Dubai, Abu Dhabi in this case. That's the overall. I just go to the last bit, which is the Tyréns bit. Over the last 9 months, we started a piece of work courtesy of the trust giving us a fund, because I was kind of inspired when I was here, when we did it at KTH. We did a little bit of work on one of the success stories in this country's waste. And I think people here don't know. So we've taken on a piece of work that is looking at the architecture of waste and how we can take that to another level, partly inspired by the project in Copenhagen with Bjarke Ingels, which we worked on, but mostly inspired by what we found in this country, how much you have actually valued waste, and I'll come to it in a second, the detail. But essentially, it's a series of, currently we're doing the diagnosis, the sampling, and the calibration with a series of people, research assistants. Tyréns are contributing in 2 ways. They've given a sum of money to pay for that, but Elizabeth Hoglan and her team here are also connected directly to Harvard. So we're basically having the conversation of how we can compare Sweden to a part that we feel is part of the USA that is the most equivalent in terms of a particular calibration, which might be population or the waste that it might create. The team looks big, but most of these are part-time people. At Tyréns, we have 3 or 4 people helping us whenever we need. We've just done the first, I would say, 9 years, and I'm just going to fly through it for you. What inspired this project, effectively for me personally, was I think that in flying into Stockholm quite a lot and learning about the waste products here, and then going to the US and discovering how bad it is over there in terms of landfill, and me being in the best city in the world, in London, where we know everything, I thought if I connect these 3 things, I could actually make some profit out of this. we're not shy about what we know, but we were inspired by also watching what other people say about Sweden. Scientists and patents in Sweden are incredible, and people don't actually know that the Global Creativity Index, I think Sweden is still at the top of that. MIT can kind of disagree with me on this, but I believe, this is Richard Florida's slide, not mine, but it is still one of the most creative countries in the world, depending on how you define creativity. So the work has started. The aim is to get the architects back and design back into energy for waste, which is just the instrument of getting the discussion between engineers, constructors, clients. So that particular building type is going to work for us. We're going to look not at the technology of waste, which we all know about, but over the next 3 years, we're going to try and produce something that, like this, which gives us some history, some projections of what's going to happen, what might happen with technology, but most of all, precedence and the architect's role in this game. Already what we're beginning to find is quite surprising. You know, if you try to do the whole of US, you go crazy. So we're sampling places, and I think we're settling on the Northeast. So our current calibration is showing how the USA, for example, the last time they built one of these facilities was in 1996. And the clusters are around this border here. If you compared areas of size or population, it's very important that we calibrate parts of the USA with Sweden rather than the whole lot. So we're just going through that. We're going to answer some questions. Of course, we're motivated by two things. The main one being how much these things cost. We've done some research to get the capital expenditure of a typical plant based on the throughput of KPA through one of these. And what is very clear, even though the construction, civil engineering is only 30% of it, is the amount of money that is spent on these facilities is incredible. So if we get this right and we move it across to the US, it could be very profitable. So some of the examples that we're looking at, you've probably all seen this data, so I'll just fly past it. And then we're looking at why we did this, why back in, before Christ, what was the moment at which we chose waste to be something that we don't want rather than as a resource. And that historical aspect is bringing out some surprises, very, very interesting surprises that we're hoping to apply. So this is just some of the work we've done, and I'm going to fly through it. This is the cluster that we've discovered that we're going to work from and compare it to Sweden. I want to get to the big slide. There are lots of imparallels. So you will see that if we try to make the USA into Sweden, this is what will happen. If we took the culture here in the way we treat waste in this country and directly translated it to the sample area, just the Northeast, we would need 10 times as many plants for them to even catch up. So commercially, even if we hit 30 or 40% success rate, we will reduce landfill, but commercially we might get a project where you can actually build some of these over there using all the history of what's been done in this country. I'm going to fly past because I can see my time is running out. Lots of work being done that is just analyzing and diagnosing the problem, trying to see how we can jump from urban sites into probably the most successful thing to do, which is to get them close to the population in the USA. This is the work we're trying to do right now. So it's not just visual, it's not just anecdotal, it's also looking at good precedences, but there's also some technological parts to it. So we are building three-dimensional associative models because the second half of the research will involve proper design studios where people will actually go on to add new program, which is inspired by this wind. So on this one, you all know there's snow on the top and there's all sorts of interesting things going on. So adding program that's beyond its current use and giving it a 100-year life rather than 25-year life are amongst the questions that we're going to ask. So that's my end. Am I on time?
Well, actually, Hanif, that was 35 minutes, so way to go. So, you're a structural engineer, right?
Yes.
When I listen to you and I look at your presentation, which is very interesting, I'm wondering what is really the difference between an architect and a structural engineer?
The education. I mean, to become a structural engineer, you're made into a convergent thinker. You have to answer the question very quickly. To be a good architect, one of the best things is to never answer the question. The best architects in the world don't answer the question. So they're divergent thinkers. They create through diversity and pluralism. We're very convergent and specialized. Now there is a benefit in both because you need to be a specialist in order to respond to somebody who never wants to finish anything. You've got to try and converge them. But I think the marriage between the two, where the best architects and best engineers understand each other, is where all the good stuff is happening. The border, the boundary.
Is there a difference in view towards these disciplines in different countries in your experience?
Yeah, without any doubt. I mean, I'm obviously I'm now a professor in architecture. So in that country, for example, there's that particular university. There's a real issue because it's the best in terms of architecture, at least in the USA. And to bring in an engineer to tell architects how to think rather than how to make is not easy. So there is a cultural difference there. At KTH, I struggled. I had 4 years here, but I found it very difficult to engage with the architects. Most of them go home at 5 o'clock, which doesn't work anyway. So there's a different world depending on where you are. I have to be very frank with everyone. London is where you get all of these mixes, the good and the bad, and the best bits are that it's a very international place. So the cultures are dissolved, and really good people are there from every discipline, from all countries. So what you're getting is this overspill between fashion, architecture, art and science happening very naturally in the bars and in outside the offices. So they're affecting the education system, which is why I've been brought to Harvard, because they want to rethink the way they teach their architects. And I think engineer schools should be doing the reverse, but they don't, because most of us don't take art seriously.
Okay. Questions? None? So your practice has won more than 250 design awards.
Yeah.
Which one of them are you the most proud of?
The two Sterling Prizes. So we won Sterling Prize in 2000 for Peckham Library. Sterling Prize is the most important architectural award in the UK. And then we won it again in 2012. We're the only structural engineer having won that, having won twice. And I'm the only structural engineer that's ever been on the jury for that, because we won twice.
Very impressive. Sorry, we have a question there. Could you use the mic, please?
Okay, my name is Lisa Derham, and I'm just curious to know about what you say about this technical engineers and architects cannot, merge, or they have difficulties in getting together and speak the same language and so on. And I'm just curious about knowing, you say London is the best place right now because of different aspects, but what should we do to get this to work on a broader level? Because London cannot just produce everything. So
No, I agree. No, I think you have to tap into that idea that the rest of the world has, that you're very creative here in Sweden, needs to move to your design culture. You have that in products, and you have that in telephones and other things. But when it comes to buildings, I haven't seen evidence of it. In fact, I quite often have discussed it in the world of architecture here. Most architects here will always favor a Japanese architect to do a building here, which is pretty pathetic when you consider how good you people could be. So what I think needs to happen, first of all, is come out of denial and educate the architects or the designers. I wouldn't limit it to the architects, because on the other side, I quite often, with present company accepted, come across a lot of PhD engineers, and they talk to me and I have no idea what they're talking about. And I find that if they were put out into the world, they're a bad advert for engineering and science. So whilst they can create value through a particular product or research, in the way we live, which is to me my essence, in the way we create our cities, it's not necessarily important to have that. What's important is how you communicate it and how you actually get to build the things that make people happier or better or richer, whichever it is. So I think one thing you can do is tap better and try to give more respect to the architects, but they have to earn that. I think the other is that the engineers need to take the architecture of buildings more seriously. Most of all, these two need to join up and start cutting the profits of the constructors, because the constructors tend to make a lot more money in these parts of the world, I think. That'll be my guess.
We have a last
Thank
question.
you.
Is this one there?
Yeah, we have one here.
It's me, Hanif. How about business models? I mean, we have a special model here in Sweden. It doesn't work the same way in the UK. We've discussed this before. The architects, you are contracted by the architects, often.
Yeah.
We are hardly ever contracted in Sweden by the architects. So in that sense, this collaboration can't really appear. It can't, I mean, we have a project manager who is owned by the project developer who would actually come and ask us for the structural engineering based on the drawings from the architects, but we never really get that close collaboration in the beginning of the project. So this is the business model working in Sweden. And would you say that this is one of the problems, that we don't get this working, or this is just educational and cultural problems?
I think it is one of the biggest problems, because when you're third removed from the client, which is what happens here, you don't get to talk about the value you bring. It's just numbers and figures. And when you're third removed, there's a lot of obstacles, usually project managers, and sometimes the architect. So the business model has come naturally to us because many clients want a particular architect. And what they say is, I can't communicate with that architect, but I want him. But these engineers can, and they can also protect my position. So we're often put into these things not by the architect, but the architect is needed by and it comes semicircular, and then we make a very good relationship with the architect, who then introduces to his next client. So it's a self-feeding business model, but the essence of it is on accepting that design has a value, and being able to design and being able to say what aspect of your project is design. You know, you don't fight every battle. You pick the moments and pick the projects, and then after a little while, the culture of your business is reflected in the value of your business as well. So today, I think we're seen as valuable, and I know also that Harvard Business School, for example, have done a case study on AKT, on the value of creativity, because people can't believe that design is actually valuable.
So, another question. Sweden is getting there.
No, I'm not saying that it wasn't. I'm saying you have to think carefully about just combining, because just combining can create archineers and engitects. This is different. The Calatrava is an example of that. They make a mess because you can't do both things at the same time. I never, ever, ever claim to be an architect, but I will always make the claim that I make every architect that works with me look better than he is, which is a very different way of being educated. So when you do combine, I mean, we're going through this at Harvard because my role is getting bigger and bigger, because they can see that I'm not there just to do projects. And what we're thinking about is creating, right now, a master's degree in design engineering. I was talking to the professor from Chalmers right now, and we're debating whether that's going to be architects and engineers only, or are we going to open it to economists, Are we going to open it to other disciplines from the school, wider school? So make it design of economy, design of politics, design of buildings and everything, but actually call it design engineering. And I think that's the kind of interdisciplinary discussion that has better value, because you don't have to suddenly become the other person. I never want to be an architect. Yeah.
Thank you very much. So Hanif, could you please keep your microphone
Okay,
if we have some questions to you later on during the panel?
Yeah.